Very good morning to all of you. This is my lecture number 3 of chapter number 14, Factorization, and this is Mathematics class of grade 8. Let us see today's topics, what we will be discussing in this lecture number 3. We will be recapitulating the concept like how to factorize using algebraic identities. And then the main topic of this lecture number 3 will be we will be learning new method of factorization, that is factorization of trinomials, and in which the factors will be of the form x plus a, x plus b. So first of all, we will recall the method of factorization using algebraic identities, and then we will be exploring another method of factorization, that is factorization of trinomials, in which factors will be of the form x plus a and x plus b. So let us recall first factorizing using identities. Dear children, you must have learned the identities in the previous lecture as well as in the previous chapter. So this is identity number 1, that is a plus b whole square equals a square plus 2ab plus b square. And identity number 2 is a minus b whole square is equal to a square minus 2ab plus b square. Identity number 3 is a plus b into a minus b is equal to a square minus b square. So we have learned with the help of few examples how to factorize the given algebraic expression using these three identities. So let us see few more examples and certain points regarding this method, that is factorization using identities. Initially, you need to express the given polynomial in the forms of a square plus 2ab plus b square or a square minus 2ab plus b square. First of all, you need to express the given polynomial in the form of this identity number 1 or identity number 2, and then replace these by a plus b whole square or a minus b whole square. This is identity number 2, that is a minus b whole square is equal to a square minus 2ab plus b square. And this is identity number 1, that is a plus b whole square equals a square plus 2ab plus b square. Another point to note is when the given polynomial is expressed as the difference of two squares, then it can be factorized by using the identity a plus b into a minus b is equal to a square minus b square. Clearly you can see that this side of this identity is equal to a square minus b square, which is the difference of two squares, and then it can be factorized using this identity. If in the question you can find this type, that is difference of two squares are given to you, then chances are we are supposed to use this identity number 3. Let us see example. Factorize x square plus 14x plus 49. Now here in this, first of all, you need to find out which identity is to be used. And it is clearly visible that it has 3 terms. Now therefore it does not fit in identity number 3. And also out of first and second identity, which identity we are supposed to use? Everywhere we can see positive sign. So clearly identity number 1 is to be used. So this is of the form a square plus 2ab plus b square. And let us see now what is a and what is b so that we can get the factors. It is of the form a square plus 2ab plus b square, where a is equal to x. It is clearly visible, a square, that is x. 49 can be written as 7 square, so we have written b as 7, such that it will be a square plus 2ab plus b square is equal to, this is a square A here is x, B here is 7 because 7 square is 49. So wherever A is present we have written x, wherever B is present we have written 7. So A square plus 2AB plus B square. So that is equal to this given expression, that is x square plus 14x plus 49. Since a square plus 2ab plus b square is equal to a plus b whole square, this identity we know. This is the identity number 1, we know this. So this expression will also be written in this manner. Like a is x, b is 7. So a plus b whole square we need to write like this. So it will be x plus 7 whole square. And it can be further written as x plus 7 into x plus 7. In NCERT book, till here it is written, but ideally it should be written like this, because x plus 7 whole square can be written as x plus 7 into x plus 7. This is also correct because in NCERT it is given in the same manner. So let us see another example. Let us see the steps first. 2 steps I am showing you and then I will be explaining. Now here it is 3x raised to the power 5 minus 48x. Now if I look at this given expression, I will not be able to use first identity, second identity, because it should have 3 terms. But here there are 2 terms. But how can I use identity number 3? This I need to find out. If x raised to the power 5 is given to you here, x is given to you here, can I take something common out of this x raised to the power 5 and x? Yes, I can take x as common, and out of 3 and 48, can I take 3 as common, because 3 is the common factor of 3 and 48. So 3 I have written outside. So 3x first I have taken common, and then I will be applying the identity. So it will be x raised to the power 4, because 1x we have taken outside, minus 16, because 3 into 16 will give you 48. So it will be 3x bracket x raised to the power 4 minus 16. Now I can use identity number 3 only if I have difference of 2 squares. Now if you look at this x raised to the power 4, can I write like this, x square square? Yes, definitely I can write like this. And 16 can be written as 4 square. So we got the form of identity, that is a square minus b square. But here a, what is a? X square, not x. And b is 4. So let us see the steps now. This expression is of the form a square minus b square is equal to a plus b into a minus b. This we have seen. So what I have done, I have applied this identity number 3, because I got the square of difference of squares, 2 squares. So it will be 3x into x plus 4, x square plus 4, because I told you a is x square. So a is x square and b is 4. So a plus b, that is x square plus 4, into a minus b, this a minus b. So that is x square minus 4. Now, dear children, can you see this? It is x square and 4 can be written as 2 square. Now here again I can apply the identity number 3, because it is again the difference of 2 squares. So it is not mandatory that in one question you are using only one identity only once. You are supposed to use sometimes 2 times the same identity, or it can be another different one. So what I have done, I have applied the identity here again, that is x square minus 4. So here a is x, b is 2. I am talking about this x square minus 4. So this part will be written as it is. Now here it will be a plus b, that is x plus 2, into a minus b, that is x minus 2. So what we have done basically in this example, first of all you are supposed to take something common, because we were not able to use either identity number 1, 2 or 3 as it is it is in the question. So what we have done, we have to take 3 common as a common factor of 3 and 48. and x raised to the power 5 and x we have taken x one time. So what we will be left with 3x bracket x raised to the power 4 minus 16. Then we have applied this identity number 3 where a is equal to x square and b is equal to 4 because 16 can be written as 4 square and x raised to the power 4 can be written as x square whole square. So we have used this identity number 3. Then again we have applied identity number 3 in this part, that is x square minus 4. Because 4 can be written as 2 square, x square is already given to us and we have the difference of 2 squares. So we can use identity number 3 again. So here a is x and b is 2. So it will be a plus b, that is x plus 2 into x minus 2. So this will be your final answer. Now coming to the main topic of this lecture number 3, that is factorization of trinomials, and in which the factors will be of the form x plus a and into x plus b. Now there are few points regarding this. When the trinomial, all of you are well aware what do you mean by a trinomial? An algebraic expression having 3 terms is called a trinomial. So I am talking about trinomials when we have 3 terms. When the trinomial is of the form x square plus px plus q, where p and q are integers, then we are supposed to use identity number 4. So what I have done, I have taken this given expression as it is equal to x plus a into x plus b. If I will multiply these two, and then I will be getting x square plus a plus b into x plus ab, and we have done the derivation of identity number 4 also by multiplying two binomials. So when I will multiply these two, I will be getting this. Now I need to relate this side to this side. Can you see now? X square, this is same. Where a plus b is present, I have written p here. And where ab is present, I have written q. So this p is to be written in two numbers in such a way that if I take the product of those two numbers, it should be equal to the sum. As I have written a plus b, so this is equal to the sum, and q should be equal to the product of those two numbers, as q is equal to ab. So let us understand this. Thus, if we want to factorize the trinomial of the form x square plus px plus q, we need to find two integers, because p has been written the sum of a and b, q has been written as the product of ab. So two integers are required, a and b, so that I can write p as a plus b and q as ab. This is basically the splitting of middle term. This can be also called splitting of middle term, because we have split the middle term, that is p, into sum of two integers and q as the product of two integers. So a plus b is equal to p and ab is equal to q. So therefore split p, what is p? That is the coefficient of x, into two parts, such that algebraic sum of these two parts is p and their product is q. I will be explaining this with the help of an example, then it will be clear to you. For example, I am taking this example, x square plus 11x plus 30. This is a trinomial, it has three terms, and if it would have been a square number here, then we would have used identity number 1 also, because we have two squares in identity number 1 but with the plus sign. So but this is not a perfect square, so we are left with identity number 4. Identity number 3 also we cannot use, because we want the difference of two squares, and so we are left with identity number 4. That is what I have explained in the previous slide. So we need to find two integers such that, what is the coefficient of x here? That is 11. I need to split this p, that is 11 here, into two parts, such that when I add them I should get 11, and when I multiply them or when I take their product I should get answer as 30. Can you find two such numbers, so that when I multiply them or taking their product it should be 30, or when I add them it should be 11? Let us see now what are those two numbers. By trial method, you need to find out the two numbers, And you must be wondering that it is 5 plus 6, it will give you 11, and 5 into 6, it will give you 30. So I have split this 11 into 2 into as the algebraic sum of two parts, that is 5 plus 6, that is 11, and 5 into 6 as 30. This is satisfying this condition. So therefore, what I have done, in place of 11x, I have written 5x plus 6x, because after adding 5x plus 6x, I will be getting 11x, and this 5 into x will give you 30. So now grouping of terms method we know, grouping of terms we need to do. Now I am taking this is one group, this is another group. Out of this group, I have taken x as common. What is left? X plus 5 inside the bracket. Now, what is the common factor of x and 30? It is 6 and 30. It is 6. X plus 5 written inside the bracket. Now, you can see x plus 5 is present over here also, here also. So, it will be written one time outside. So, it will be x plus 5 into x plus 6. So, the factors of this expression are x plus 5 and x plus 6. I hope, dear children, you must have understood this factorization using identity number 4, or factorization of trinomial of the type x square plus px plus q. And basically this method is splitting the middle term also, because we have expressed p, that is the coefficient of x, as the sum of two integers, and q as product of those two integers. Now this was the main topic of this lecture. Now coming to homework part of this lecture, you are supposed to complete question number 2 and question number 3 of exercise 14.2 in your homework notebook. Those who have not completed question number 1 all parts, they are supposed to first complete question number 1 as well as 14.1 exercise, and then they are supposed to complete question number 2 as well as question number 3 of 14.2 exercise. Now let us see the homework solutions from NCERT exercise 14.1. Find the common factors. Question number 3 first part is find the common factors of the terms x square plus xy. I will be explaining these parts. I am showing all these parts. Rest parts you are supposed to do on your own, and you must have done it, I think. So by the time your exercise 14.1 should be complete after the discussion of this question number 3. So let us see all these parts one by one. First of all, I am showing the solution of question number 3 first part. Here, first of all, you must have observed that there are 4 terms. Then we can go with the grouping of terms method. We need to factorize basically. So, dear children, I am showing you these steps. This step is not at all required, but I am showing you so that you can understand in better way. But ideally, you are supposed to do this step. This step is not at all required, but for your understanding, I am doing it initially. But you are supposed to write the direct answers after you have understood, after understanding these. So what I have done, I have made the group of these 2 terms, and these 2 terms are under one group. So x square, I have written x into x plus x into y plus 8 into x plus 8 into y. This step is not at all required, but I am writing it just for you so that you can understand it in a better way. But ideally, you are supposed to write this direct step. So from this group, what I can take common? X common, bracket x plus y, plus, can I take this 8 common? Yes, 8 I have taken common. What is left? X plus y. So this is x plus y. This is common, so it will be written outside. X plus y into x plus 8. These will be the factors. Coming to solution of second part, it is 15xy minus 6x plus 5y minus 2. Now, I have first of all written the factors of all these terms separately, that is 3 into 5 into x into y, likewise 3 into 2 into x plus 5 into y minus 2. So this step I am writing for the students, those who are unable to understand. So ideally your step should be this one. So what I have done, I have taken the group of these 2 terms and these two terms are under one group. So 3 I have taken common, x I have taken common. So out of 15, 15 and 6, what is the common factor of 15 and 6? 3 I have written outside. X, y and y, x, what I can take common? X. So what will be left inside the bracket? 5y minus 2. Here also you can see 5y minus 2. This minus sign also. Plus. Now, can I take anything common out of this? No. But can I write one common out of these two factors? These two terms? Yes, I can write one. So, 1 I have written. This term will be written as it is. So, it will be 5y minus 2 into 3x plus 1. So, these two are the factors. Coming to solution of fifth part, it is z minus 7 plus 7xy minus xyz. First of all, you need to see the groups. Let us see now what I have done. I have made the group of z minus xyz. This is your one group, and these two terms are under another group. But dear children, you can do the grouping of z and minus xz also. Sorry, this I have done. You can do the grouping of z minus 7 as well as this also, but that will in that grouping there will be a difference of minus sign. Then you need to take minus sign common. So by the time, first of all, understand this method, then I will be explaining that method also. So I have made the group of first and last term plus second and third term. So I have written the factors like this. First of all, this step is not at all required, but for your understanding I have written. I am repeating these things because you need to write the direct answers in the exam. So from the first group, z can be taken out. In the bracket I can write 1 minus xy, minus 7, 1 minus xy. So what will be the factors? 1 minus xy. So what will be the factors? 1 minus xy, bracket z minus 7. 1 minus xy, bracket z minus 7. Now coming to homework solutions of exercise 14.2, question number 1. Factorize the following expressions. These are the parts which I will be discussing. These 4 parts I will discuss. Let us discuss third part first. I am showing you the steps, then I will be explaining the steps. 25m square can be written as 5m whole square. Plus, everywhere plus sign is there, and these two are squared, so we can use identity number 1. So 9 can be written as 3 square. Now 2ab we need to write. So 2, here what I have written, 5m into 3. So a here is 5m, b here is 3. So a plus b whole square. It can be further written as a plus b into a plus b, because square was there, so it will be written 2 times. So using identity number 1, that is a plus b whole square is equal to a square plus 2ab plus b square, and taking a as 5m and b as 3. You need to ultimately complete the squares and get to know the values of a and b, and then put it equal to the given side of the identity. Now coming to solution of fifth part. Let us see the steps, then I will be explaining. This is 4x square, this is also a square, 4 is also a square. Now minus sign is there, so I can use identity number 2 there. So it is 2, 4 can be written as 2 square, x square can be written as x square. So 2x will be written inside the bracket, minus 2ab. A here is 2x, b here is 2. So plus b square. 2ab, 2a is 2x, b is 2. So what is it equal to? A minus b whole square. So we have written 2x minus 2 whole square. Can I take 2 common out of these two terms? Yes, I have taken 2 common. So what will be left? X minus 1 whole square. And we can write further like this. 2 square I have taken 4, x minus 1 whole square. Then it can be written like this. So using identity number 2, a minus b whole square is equal to a square minus 2ab plus b square. Taking a as 2x and b, it should be b here, b as 2. So solution of 7th part. First of all, look at this. It is a plus b whole square. First of all, you need to apply identity number 1 for this part, and then you can solve it. Let us see how it is to be solved. It is a square. A here is L. B here is M. So a square plus 2ab plus b square minus 4lm. Now minus 4lm and 2lm, these two are like terms. Can we solve them? Yes, definitely. So using the identity number 1, I have written the identity considering a as L and b as M, as I have explained. So I have solved now these two terms. Minus 4 plus 2, it will give you minus 2. Lm will remain with both the terms. So these two are like terms. So we have written minus 2 Lm. So now this is a square, this is a square. Now minus sign is there in between. Can I write like this? It is a minus b whole square now. So it will be written further 2 times. Coming to 8th part of the same question. Now let us see the question first. It is a raised to the power 4 plus 2a square b square plus b raised to the power 4. Now to apply identity number 1, I should have 2 squares, that is a square plus b square plus 2ab. So but here it is a raised to the power 4. So can I write a raised to the power 4 as a square square? Yes. B square square can be written as b raised to the power 4. So here a is not a. In identity, as we need to write a plus b whole square. So it is a square now, not a only. So I have written the identity in terms of x and y here. So it is a square, that is a square square plus b square square plus 2ab. 2a is a square, b is b square. So it will be a plus b whole square. So actually what I have done in this part, I have written the identity in terms of x and y because already a and b is mentioned in the question. So now you will be able to understand x plus y whole square is equal to x square plus 2xy plus y square. Here x is a square and y is b square. So I have written this form of the expression was given to me. So I need to write this form. So it will be a square, that is x square, x plus y whole square. I have written x plus y whole square. So taking x as a square and y as b square. I am explaining this part again. Basically, a raised to the power 4 can be written as a square square. B raised to the power 4 can be written as b square square. And we are left with plus 2ab. So it is, I have written the identity in terms of x and y. It is x plus y whole square is equal to x square plus 2xy plus y square. If you will compare these two sides, you will come to know that this should be written in this manner. So x is a square, y is b square. What I have done? X plus y whole square, that is a square plus b square whole square, and it will be further written like this. So taking x as a square and y as b square. Thank you so much. So dear children, you are supposed to complete exercise 14.1 and question number 1, 2, 3, all the parts of all the 3 questions, and along with that question number 1 of exercise 14.2 should be complete now. Rest questions 2 and 3 I have given you for homework. Then I will be discussing those questions and then you will be able to understand them properly. I hope you have understood all these concepts taught in this lecture and you will be able to, definitely you will be able to solve the questions. Thank you so much.